Welcome to Python Lab Week 1 video submission. I'm Mandan MS. So today we'll be solving a Python problem. For that, the agenda is we have to understand the problem statement. Then we have to find the different approaches to find the solution. And then we will be going through a code implementation. Then a conclusion will be drawn for the two approaches. Okay, basically the problem statement is that a list will be provided. In that list we have to find the sum of the two numbers which is nearest to 0. That is, if we add any two element, it has to be nearer to 0. If we example -4 and -7, answer will be 3. If we consider this 6 and 5, the answer will be 1. That in that case 1 will be nearer to 0. So this is the problem statement. The hint is some hints are given, that is absolute distance of the sum from 0 should be considered to find the sum of the closest 0. Then the maximum possible sum of the elements is given, that is 10 to the power of 9, and we can use a sort function. I'll show you where it can be used. So this is the problem statement, and these are the outputs, test cases which were provided for our reference. So there are two approaches we have taken, that's a brute force approach and a two-pointer approach. The brute force approach is an approach, it is a daily day-to-day approach where a simple basic solving technique is used, where a time complexity is not considered, where the iterations can take place n number of times without any time complexity. But in a two-pointer approach, we will be considering the 2 points, where at a time a 2 point will be considered, and the solution and the iteration goes very quickly, taking the two elements at a time. So the time complexity of this approach will be less. So going through this brute force approach, these are the steps which we have considered. So the thing is, what are the coding steps I have taken for this brute force approach to solve this problem? I have mentioned the steps. So what I have done is I have defined a function basically at the initial stage, and I have considered an empty dictionary. I have created an empty dictionary at the start of the program to find that sum, absolute sum of the two elements, which will be added during the continuous iterations to the dictionary. So I've considered for loop. The for loop is used for the iteration of the list for summation of the two elements. We have used two for loops because we have to consider two elements. So we have used two for loops to find the sum of the two elements. In that, we have used the if condition. If this current sum of the two elements is smaller, then during the continuous iteration, a smaller element will be updated to the minimum value. So then when we find a minimum value, then those two elements of that minimum value will be considered at the final result. And the two-pointer approach. In this two-pointer approach, what we have done is we have considered the two pointers to traverse to the list of list simultaneously from the both the ends. In that same thing, we have defined a function to find the minimum pair. Then we have done a sorting. Why the sorting? Because in a two-pointer approach, sorting is very important in a list. Then initially we have considered a minimum sum to the defined value, that is minimum sum for that largest element, that is 10 to the power of 9 as a hint was given, and the minimum pair to a none. Then we have set a two pointers for this approach. As first I have considered the left pointer as 0 and a right pointer as the last index of the sorted list. Then a while loop is applied, stating that if the left pointer of this if this left pointer is less than this right pointer, obviously it will be less in the first stage, is less, then we have to then we have to calculate the sum of the elements at the left and the right pointer. That is, a new element will be generated, that is current sum of this both elements. Considering both these elements, then we have to take the absolute value of this current sum. Then if this absolute current sum which we have got, if it is less than this minimum sum, obviously it will be less in the first case. If it is less than this minimum sum, then we will update this current sum to this minimum sum. So this continuous iteration will take place till we find the minimum pair. Then minimum pair will be updated of the element which is of minimum sum. For that, we have again applied a if condition stating that if this current sum is negative, if we get a negative solution, then we have to move this pointer by 1. That is, you have to increment this by 1 for that for loop. And then if we get a positive, then we have to decrement the right pointer by 1. This is the solution approach. In this first, as I stated in the brute force approach, this is the brute force approach. I have defined a function of sum closest to 0 with for this element. Then I have opened a new dictionary to after continuous iteration we have to store a minimum number. For that we have opened a new empty dictionary over here. Then I've considered this maximum value as 10 to the power of 9 as stated. Then I've used a if condition, because if in some case if the input is given in a single element, that solution cannot be done, because we need two elements to go through in this particular problem. So if it is in a single element, it will be an invalid solution. Then we have applied the two for loops, because as you know, we have to consider the two elements. In the first for loop, I have considered the range from the first to last, and in the next one will be after iteration by iteration, it will go one step next to this I. If it is I, it will be considered range from this to this. Then after that, in the first step, after the first iteration, what will happen is, uh, if we consider the elements of I and j in the first case, if it is if it is I and j, if we do a absolute sum, our answer will be obtained. Example, for in this case 3 will be obtained. If this, then if condition is applied stating that if this absolute value 3, which is if it is less than this sum, if it is less than this sum, obviously in the first case it will be less, then that minimum sum will be updated with this minimum sum which will be getting, that is 3. Then this minimum sum will be 3. Then after continuous iteration will be taking place till we find a minimum number, which is the minimum number. If it is not a minimum number during iteration, it will not be updated. Then we'll consider the two elements of this minimum number and we'll get a solution. For if it is in a two-pointer solution, as we mentioned, I've defined a function. I've sorted. Basically, sorting is very important in a two-pointer solution. Then the minimum number is defined and the minimum pair is defined. Then a left pointer is updated to 0 and the right pointer is updated to the length of the list. Then if same if condition is applied, if it is a one element, then a while condition if is applied stating that if this left element is less than right element, obviously in the first case it will be less, then this current solution, in this current solution, this left and this right solution if will be summing and we'll be calling it as current sum. If this absolute sum is less than this minimum sum, obviously it will be less, then it will be updated to this minimum sum. Then example, this minimum sum will be updated to this current sum. Then this current sum will become this minimum sum, that is a minimum value. The continuous iteration will take place at the end, whichever is the minimum sum, that value, two elements will be considered as a minimum pair. For that iteration also, if we have stated a if condition stating that if this current sum is less than this 0, that is negative, will be incrementing by 1. If it is not, it will be decrementing by 1. then we'll be returning it. So this, as the approach states, this two-pointer approach is having a less time complexity than this brute force approach. Thank you.